All right, let's do what we can, and I think we're going to need to finish it up, start it next time. All right, so if you roll regular six-sided die twice, you guys already know about that. We already did that. Right, we did number one. Roll regular six-sided die twice, probably both rolls, same parity, right? So for both these, it's all about the 6x6 chart, isn't it? So you're going to have that on your 3x5 card for tomorrow, right? You know, the 6x6 chart, which shows everything that can happen when you roll a die twice, or two dice at once, whatever, same thing. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 1, 2, 2, 2, 3. 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay, so there's everything, 36 different things that can happen when you roll a die twice, or one, or two dice at once. Same thing. All right, so they're saying, what's their question, everyone? At least one will be even, right? We did this one other time. At least one is even. Well, that'd be 1, 2, 1, 4, 1, 6, first off. They all have one even number, at least one even. The next one, it's the whole row, the whole column, because their first number's even, so of course they got an even number. The next one, the 2, the 4, the 6, because those are even. And the 4s, the whole column of the 4s, because the first number's even. And then the 5, 2, the 5, 4, and the 5, 6, and then the whole column of 6s. So 3 numbers plus 6, three different results plus 6 results plus 3 plus 6 plus 3 plus 6. If you add it all up, it's 27. 27 of those boxes have at least one number that's even out of 36. Right? It's 20 because there's 36 total boxes, 6x6 array. So it's the probability, if you roll two dice, that you'll get at least one of them even is 27 out of 36. Reduce that fraction. Divide top and bottom by 9. 3/4. The chance is 3/4. Answer A. Does that make sense? Probability that at least one of the two numbers will be even. I just looked at the 36 results, circled all of them that have at least one even number. And I got 3 in the first, and then 6, all 6, and then 3, and then all 6, and then 3, and then all 6. Add them up. 27 of the boxes. 27 out of 36 of the boxes have at least one number even. Reduce the fraction, 3/4. Is that good? Questions on that? Now, number 2 is very, very similar. Same kind of thing. You roll the two dice, same parity, meaning both even or both odd. So, if I can do a different color here, I don't want to redraw the chart. How many of those have both even or both odd? Well, this is both odd, both odd, both odd, because it starts odd, so the only chance is to get both odd. And then both even, both even, both even in the next column. Right? See what I'm doing there? And then the next one, both odd, both odd, both odd. And then you see it's just every other one. Both even, both even, both even. Both odd, both odd, both odd. Both even, both even, both even. Like a song. Right? So it's 3 in every column. 3 of the boxes in every column. Add that up, 18 boxes. So in other words, 18 out of 36. Reduce the fraction. Divide by 9, top and bottom. Be 2/4. Reduce it again, half. So answer D. Half of the boxes have both even or both odd. When you roll two dice, there's a half chance you're going to get both even or both odd. Good on that. So the two dice thing, you just lay out the 36 boxes, 6x6 array, and you just circle the ones they're talking about. Reduce the fraction. All right, I'll move on from there. Okay, so a coin is tossed twice. Remember what that means? It's heads or tails on the first flip, and then from there, it's heads or tails on the second flip. So the overall results, there's 4 different things that can happen. Heads then tail then head, or tail than tail, huh? 4 different things that can happen when you flip a coin twice. So what's their question? Probably that both tosses come up heads. It's 1 out of the 4 different things that can happen. Answer B. That good? Good with coin tossing and die rolling? Same thing down here. Fair coin is tossed twice. Probably the least one will come up head. So, well, here, you're okay, I'll move on. So, at least one. So, again, the 4 things are head, 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 tail, tail, head, tail, tail. And it says at least one is heads. Well, that'd be all 3 of those have at least one head, don't they? Right, 1 or more. So 3/4 probability that you'll get at least one head when you toss a coin twice. And now part number 5, you're tossing the coin 3 times. So now on number 5 we're doing it 3 times. We actually did that as well. So that's heads or tails the first time on the first flip. The second flip is heads or tails. Oops. And then the third flip is heads or tails. Getting kind of squished in there. Oh, we don't got room. Don't got room, don't got room. Okay, so that's the third flip. So when you flip 3 times, you could get heads, heads, heads. You could get heads, heads, tail. You could get head, tail, head. You could get, what's that, head, tail, tail. You could get tail, head, head. You get tail, head, tail. You could get tail, tail, head. You get tail, tail, tail. There's 8 different things that can happen when you flip a coin 3 times. It doubles every time, huh? 2 things, 4 things, 8 things. Just keep telling you. Flipped it a 4th time, then we're not going to do that on the test. There'd be 16 different things that can happen. Anyway, what do they want? Probability of tossing all 3 heads. Oh, all 3. So there it is. It's 1 out of 8, huh? Good. Keep moving. Number 6, pair of honest dice rolled. Number on each die is noted. What's probability of totaling 7? All right, so, yeah, I'm going to roll up for that, actually. So remember, again, that's the 6x6 array, right? So I'm going to do the 6x6 array, which you'll have on your 3x5 card, I hope. And 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay. Getting scribbly at the end. Getting tired of making that array. All right. So how many of these then? What do they want? Probably a total of 7. Total of 7. Remember, that's the most likely result. That's right down the main diagonal here. Those all sum of 7, aren't they? So there's 6 out of 36 boxes that have a total of 7. Reduce that fraction, divide top and bottom by 6. It's 1/6. I think we did this one before, didn't we, on a quiz or something? 1/6. And then question 7, rolling neither 7 nor 11. We did that one also. So here's the 11, sum of 11. There's 2 boxes. So there's 8 boxes that are 7 or 11, right? So 36 take away 8 is what? 28 boxes that are neither 7 nor 11. Does that make sense? Out of 36 boxes total, 6 and 2, 8 of them are 7 or 11. So subtract from 36, 28 boxes are neither. So the probability then is 28 out of 36, isn't it? 28 boxes are neither 7 nor 11. Reduce that fraction, divide by 4. What is that? 9, no, 8, 7, I'm having trouble here. 7 ninths. 7 ninths, yeah, there it is. 7 ninths. That makes sense. If I top and bottom by 4, reduce that fraction. I think we did this one too, didn't we? On a quiz one time, or talked about it or something. Anyway, we good with that? Questions on that? You all good? All right, so all those dice ones make the 6 by 6 array, and the coin ones make the heads, tails. Okay. So how many different passwords are possible? What are we doing? Computer password consists of any 5 capital letters, period. It's just any 5. So remember, I always do one. All right, W-A... B, F, C, WAB, whatever. Anyway, so I just picked a password, which is 5 letters. Okay, so I made 5 decisions. How many options did I have for each of those decisions? So my first decision, how many options did I have? 26. Well, there's 26 letters in the alphabet. They said I can pick any letter I want. Times 26 times, each of these decisions where I picked a letter had 26 options. That's 26 to the 5th power, which is B. That good? Not 26 times 5. It's 26 to the 5th power. All right. Number 9. How many different start? I can't read it down there. What is it? Start with the letter Z and end with W. Okay. So now I got to pick one. So I'm going to pick one. Remember, I really do it. Start with Z, and then I'll go M-A-C, and end with W. So you got to start with Z, end with W, pick whatever you want in between. So I made 5 decisions. First decision, I only had 1 option. Last decision, I only had 1 option. Because I had to start with Z, and I had to end with W. Right? You with me? Whenever they tell you, whenever they fix a spot and say, make sure this happens here, then you've only got 1 decision there, 1 option there. All right, so then the rest are 26, though, aren't they? So multiply those together, that's 26 to the 3rd power, which is D. Good there, all right. Number 10. Okay, this time, last with 5 capital letters. Oh, except for the letters O, I, and Q. So they're ruling out 3 letters. No O, I, and Q. All right. So 5 letters again. So 2, 3, 4, 5. So that means that there's 3 letters you can't choose from. There's 23 options, huh? 23 options. Right? So 23 to the 5th. Is that there? Is that one none of the above? I'm confused. Maybe I better read more carefully.
It starts with Z and ends with W.
And last week consists of any 5 capital letters in order. Oh, thanks. I better read, huh? Yeah, and it starts with Z and ends with W. Thank you. So we're still doing the start with Z and with W thing. So that only gives me 1 option here and 1 option at the back. And 23 to the 3rd, so A. Does that make sense? They just ruled out 3 letters. They said you can't do O, I, or Q, so we only have 23 options instead of 26. And we still have to start with Z and end with W, so there's only 1 option at the front and the back, 23 for each of the others, 23 to the 3rd. Number 11, how many lifespans begin with the word math? So you could go like math A, or math B, or math C, or math D, or math E. Yeah. How many options begin with that? Can you just tell? How many different, it's all about the letter you put at the back, huh? Let's just be real about it for a second. How many different license plates are possible? If you got to start with the word math, there's only 1 more letter to go. There's 5 letters, so 1 letter at the back. So how many different options for what goes back there? Well, 23, right? Because there's 23 options back here. All these guys are just 1 option, 1 option, 1 option, huh? And there's 23 letters to choose from because, remember, because again, they ruled out O, I, and Q. Right? Those instructions, everybody know how the instructions, I don't want you to be confused by that on the test. Whenever they give instructions, it applies to all the problems below it until new instructions are given. Right? So those instructions about no O, I, and Q apply to both 10 and 11, right? Does that make sense? That happens even if the problem goes to a new page, so you got to kind of watch out. If If you're ever confused, well, which instructions? Look back to the last time instructions were given. They hold until new instructions are given. So it's just 23. Just 23 letters can go in the back because you can't use O, I, and Q. M-A-T-H, math, there's only one option for each of those. Right? You can do math A or math B or math C or math D or math E or math, all the way through the letters, except you can't use O, I, or Q. 23 different license plates. Makes sense, doesn't it? Good? Moving on. I put a lot on this practice. I want you to see everything. All right, number 12. Tasmania, da-da-da-da-da. So this time it's 4 letters, then 3 digits, 0 through 9. Okay, so I'm going to, 4 letters. A, B, C, D, and 2, 7, 9. So 4, I just did one. So 4 letters, 3 digits. Okay, what did I do? 26 options, 26 options, 26 options, 26 options, 10, 10, 10. You good with the digits? Each have 10? Right? Because the digits are 1 through 9, which is 9, and then 0 makes the 10th digit. So there's 10 options for this. So you just multiply those. Oh, here it is. 26 to the 4th times 10 to the 3rd, huh? Good? Number 13. End with 66. So if you got to end with 66, A, B, C, D, 5, 66. All right. How many options? 26, 26, 26, 26. Right here, you can pick anything you want, 10. But here, only 1 and 1. Make sense? You can pick any digit you want here, but then the last 2 have to be 66, so there's one option, one option. So multiply that together. 26 to the 4th times 10. Yeah, B. Good, and one more. License plate. How many start with the word add? So we got add, and then maybe W579. So one option, one option, one option, because they make us write add. And then W, 26 options, 10, 10, 10. So there it is. It's 26 times 10 to the 3rd. Oh, that's 26,000. 10 to the 3rd is 3 zeros. 26,000. Good on all those license plate problems. I'm going to keep moving. Number 15. French restaurant offers a menu consisting of 5 appetizers, 3 salads, 2 soups, 7 main courses, 3 desserts, blah, 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 blah. Monday through Thursday consists of appetizer. There's a lot of words here. Appetizer, soup, main course, dessert. So you don't pass on any of these. How many different fixed price dinners are possible on these days? All right. Let's read it carefully, I guess. So what are we doing? We're doing an let me write it out, kind of. We're doing an appetizer. Appetizer says appetizer, soup, main course, and dessert. All right. How many options? Well, let's look up here. So let's say 5. 5 appetizers times how many soups? 2 soups. How many mains? 7 main. How many desserts? 3 desserts. Multiply those together. 210. Is that good? See what I did there? I just wrote out what they were saying in 15. Appetizer, soup, main, dessert. Looked above, found the number of options for each, multiplied them together. Right? Decisions, options, multiply together. Next one. Fridays and Saturdays, whatever. Blah, 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 blah. Appetizer. Choice of soup or salad. Let me write that. That's one decision. You're not getting soup and salad. You're getting soup or salad, right? Main, dessert. Okay, so let's say appetizer 5 times. Now, soup or salad, how many, if I'm going to choose, that's one decision, right? You choose your appetizer, 5 options. Then you choose your soup or your salad. Well, how many options total is that?
5.
Yeah. There's 3 salads, 2 soups. You can choose any of the 3 salads or 2 soups. There's 5 options for the soup or salad option, right? Does that make sense? And then the main is still 7, and this is 3, and that's some big number. 25, so I don't know, what is that number? 75, 490 and 525? Yeah, B. 525, B. We good? All right, 10p3, you can do that on your calculator. I hope most of you can just do that right on your calculator. If not, I'll again write out the by hand. The by hand is you start at 10. If you have to do it by hand instead of by calculator, I'll write again for you how to do it. So start at 10, do 3 numbers. 10 times 9 times 8, 720. Calculator will do it automatically. Remember how that works? Start at 10, do 3 numbers. And you're always going down. 10 times 9 times 8. The number 18 is almost the same. 8C3. You start at 8 and you do 3 numbers. So start at 8. 8 times 7 times 6. Right? But then you cut. You divide by 3 all the way down. Oh, can't even see that, huh? Here, I'm going to go to a fresh screen, if that's okay. Okay, so where are we at? So 8C5. Again, you start at that number. Was it 5? Did I just do the wrong one? Did I do a different one? What did I just do?
What you did was cut 5 and 4.
Start at 8. Do 5 numbers. Right, so start at 8. 8 times 7 times 6 times 5 times 4. There's start at 8, do 5 numbers. That's 5 numbers, right? And then the second number is factorial. 5, 4, 3, 2, 1. Second number down to 1. So that's how you do the C. The C is different than the P. Everybody aware of that? Again, I showed everybody, almost everybody, how to do it on your calculator. So you just hit the buttons on your calculator and get it. But if you're one of those that needs to do it by hand, let me be clear with you again. The difference between C and P, they both, the first number you start at, the second number is how many, but the C cuts it. It divides it by the second number all the way down to 1. Whereas the P, yeah, I did 3. I changed the problem. Forget that. Anyway, the P just starts at 10, does 3 numbers. No dividing, no bar, no fraction, no cutting it by anything. Just straight. The P is just straight. Start at 10, do 3 numbers, done. Right? Whereas the C, start at 8, do 5 numbers, and cut it, divide it by the second number all the way down to 1. That's the difference. So 5, 4, 5, 4, 5, 4, 3, 2 is 6, 3, 2 is 6, 56. B. Good? Moving on to the spinner. I can barely get halfway. All right, so spinner problem. Spinner, shown below. Regions 1 and 2, 90%. Okay, so what do we got to add them all up? 100 degree, fours. So we just got to, all the way around is 360, huh? All the way around is 360. So you just got to add up all the, angles 1 and 2 are 90. So that's 90 and 90 for angle 1, angle 2. Angle 3 is 100. Angle 4 is 60. So just add all those up. 180, 240, 340. So angle 5 then must be 20 degrees. That's all that's left to make 360. You with me? I just added up the angles they gave me. 290 160 makes 340. And then I take 360 minus 340. That's the last angle must be 20 degrees. Okay, so what's the probability? It's 20 out of 360. Because remember, you always go over the total. So if you're spinning that spinner and you're hoping to land in region 5, you have a 20 over 360. Reduce it by 10. And that'd be 2 over 30. Just cuts off 0. Divide by 2, 1 and 18. That's your probability. Is that good for the angles? All the way around a circle is 360. Okay, question 20. Oh, okay, this is where you lay out the probabilities and do all that kind of stuff. Okay. Okay, if I flash off to that. So 4 drivers are entering a race. According to odds makers, probably the driver A will win is 0.4. Other drivers have equal. So there's A, B, C, and D. A is 0.4. The other 3 says all have equal. So X, X, X. Right? Remember how we did that when we did the other one like this? If they're all equal, you call them all X. And then if you add them all up, what do they have to add up to equal? 1.0, because that's 100%. Like if I said the chance of rain is 40%, then the chance it's not going to rain has got to be 60, because that adds up to 100%. right? And 1.0 is the decimal version of 100%, right? We're doing decimals, 0.4. So that's basically 100% right there. I say somebody's going to win the race. It's going to be A, B, C, or D, right? So it's either going to rain or not rain, right? They got to add up to 100%. The chances, it's got to add up to 100%. It's got to add up to 1.0 decimal, which is the same as 100%, right? Okay, so that means you got a little equation. 0.4 plus 3x is 1.0, huh? Right, x plus x plus x, 3x. Is that good? And then solve for x, subtract 0.4. So 3x is 0.6. Last step to get x alone, divide by 3. So x is what, 0.2? Oh, wait, okay, now I got to read the question a little more carefully. What is probably the driver we will not, look at that little not, they're being tricky, they're trying to trick us. What's the chance that B will not win the race? B will not win the race. So for B, it's X, like C and D are the same thing. The chance that B is going to win the race is 0.2. So what's the chance not B? So B is 0.2. Here, I'm running out of room here. B is 0.2. Like there's a 20% chance of rain kind of thing, right? The chance it won't rain, chance it's not B, is 0.8, huh? Got to add it to 1.0. With me on that? 0.8, there it is. And then 21. What are the odds that driver D will win? Odds that driver D will win. Can I flash off that? You got that down okay? Odds, so again, we had, what do we have? A, B, C, and D. This was 0.4. These were all x, and we solved for x. They're all 0.2, aren't they? That makes sense. That adds up to 1.0, right? 4, 5, 6, 7, 8, 9, 10, 1.0. So, okay, now what are they saying? Odds. Now, remember how odds work? So, probability that D wins is 0.2, which is what? 2/10 or 1/5. You with me? Now, so what does that mean about the odds for D to win? Well, probability is 4 over total. Odds is 4 colon, or the word 2, whatever you want to do, against. So remember, odds is like a debate, for and against, right? So if there's 1, 4, so it starts the same, 1, 2, right? Because odds begins with 4, just like probability on the top is 4. But the ending of probability is total. The ending of odds is against. So if it's 1, 4 out of 5 total, then it's 1, 4, how many against? 4, 1 to 4, to make 5 total, right? If there's 5 people in the room and 1 are for the issue, then there must be 4 against it. 5's the total. So remember, probability is over total, odds is for and against. Probability is 4 in total, odds is for and against. So if there's 5 total, 1 is 4, there must be 4 against. So 1 to 4, answer C on that. Now what if they had left it 2 to 8? Right, because if I didn't reduce this, I would have had 2 over 10. Right, and 1/4 is the same as 2/8, right? It is. It's just not reduced, but it's the same answer. Does that make sense? If I say there's a 2 in 8 chance of rain tomorrow, that's the same as saying there's a 1 in 4 chance of rain. That's the same thing. Right, so I want to say that because I believe there's one on the exam tomorrow where like they leave the answer that way, and sometimes people get fooled. The publisher just made it that way. I don't want you to be fooled by that. That's the same answer. It never said you have to simplify, right? So if they had the answer there, 2 to 8, I would grab it. I would not choose none of the above. 2 to 8 would also be valid. If they said 2 to 8, I would have grabbed that also. They wouldn't put both, right? They put either one or the other. Does that make sense? So don't be fooled like, oh, they're trying to trick me, they didn't reduce it. No, it never said you had to reduce it. That would still be valid answer. So grab that one. Well, we are out of time. Look at that. Man, what we get? Halfway barely? Not even. 45? Not quite. Wow, all right. So we're going to have to spend time tomorrow. We'll spend our first maybe half an hour going over that thing, making sure that I do the rest of it with you. There's a couple tricky ones with the bell curve. So take a look at it. I'd encourage you. You know what you guys could do? This is what I would encourage you to do. Go on, let me show you real quick. Let me stop this part real quick.